7.2 goes over rational exponents. What rational exponents are just fractions as exponents or powers that are fractions. When you're working with these fractions as your powers, your numerator is going to be your power that stays on the term that it's attached to, and your denominator is your index. So your index goes on the radical and is attached to the radical. If your number underneath the radical or your terms underneath the radical do not have a power, it's automatically a 1. So that index is going to go under 1. If we look at example 1a, we have the cube root of 35. Now this is the same exact thing as saying the cube root of 35 to the first power. So if your 3 is your denominator and your 1 is your numerator, this is going to give us 35 to the power of 1/3. For example B, we have the fourth root of xy. Now with this one, that xy is attached to each other by multiplication. So I want to rewrite this as saying the fourth root of xy and put parentheses around the xy. That xy is being raised to the first power, so this 4 is your denominator, the 1 that is your power is your numerator. So we're just going to have xy, keep it in parentheses, to the power of 1/4. For example C, we have 5 to the power of 1/2. That 1 on your power is your power that's going to stay on the 5. The 2 that's your denominator is going to be your index. So whenever you have these, your numerator is your power that stays with the term that it's attached to, then your denominator is your index. So we're taking the square root or the second root of 5 to the first power, which is just the square root of 5. For example D, we have a to the power of 1/5. Again, the numerator is going to be your power, denominator is going to be your index. So this is going to give us the fifth root of a to the first power. Now this is the same exact thing as just saying the fifth root of a. The next part of your lesson just goes over evaluating each of these expressions. So we're going to turn them into we're going to turn the exponential expression into radical form and then simplify from there. For example, 2a, we have 4 to the power of 1/2. The 1 is going to stay the power, the 2 is your index. So we're taking the square root of 4, which is just 2. For example, B, we have -8 to the power of 1/3. So again, the 1 that's your power is going to stay the power, or the 1 that's the numerator, is going to stay the power. The 3 that's your denominator is going to become your index. So we're doing the cube root of -8 to the first power. That -8, we're going to circle the negative to make sure our answer has that negative, because we are okay to do that and keep it because our index is odd. That 8 is 2 and 4. 4 is 2 and 2. We need 3 of the same number. We're going to remind ourselves of that negative, and we just have -2 for our answer. For example C, we have 81 to the power of 1/4. Again, the 1 that's your numerator is going to be your power. The 4 that's your denominator is going to be your index. So we're going to be taking the fourth root of 81. The 81 is 9 times 9. 9 is 3 times 3. Our index tells us we need 4 of the same number. We have 4 3s, so the fourth root of 81 is just 3. For example, D, we have -9 to the power of 1/2. Now this -9 is in parentheses, which means the negative as well as the 9 goes underneath whatever root we're going to be taking based off of that 1/2. That negative, because it's in the parentheses with 9, the only thing that tells you is that you're not only raising the 9 to the 1/2 power, but the negative as well. So with this, the 1 is your power, 2 is your index. We're taking the square root of negative 9. We have that invisible index of 2. That index is even. We cannot have a negative underneath the radical if our index is even, so this is no solution. For example, E, we have negative 9 to the power of 1/2. Now, this 1/2 is only attached to the 9, not the negative. So this is like saying the opposite of 9 to the 1/2 power. Again, the 2 is your index, the 1 is your power. So this is saying take the opposite of the square root of 9. The square root of 9 is 3, and the opposite of 3 is negative 3. The next part of your lesson just goes over rewriting these expressions. If it's in radical form, rewrite it using exponents. If it's in exponential form, rewrite it using radicals. If we look at example 3a, we are given the cube root of 2. This 2 is not raised to a power, so it has an invisible power of 1. So your index is your denominator, your power is your numerator. So this just gives us 2 to the power of 1/3. For example B, we have 1 over the 4th root of m cubed. First off with this, we want to turn this fraction into just a number. So if you remember, when we worked with negative powers, you took the reciprocal of the term that it was attached to. In order to turn this fraction into a whole number, you're going to have to work with a negative power. If it was me, I would first simplify the denominator and turn it into m to a power of something. If I did, this 4 is my index, so that's my denominator. My 3 is my power, so that's my numerator. This would give us 1 over m to the power of 3/4. Now again, I don't want this as a fraction. I want it as m to the power of something. So take the opposite of the power of 3/4 and it becomes m to the power of negative 3/4. If you ever are weary of this or question whether or not this is the correct answer, work backwards. Take your answer and just move it into radical form. If you turn the negative into a positive, you take the reciprocal of the m to the power of 3/4, which would turn it into 1 over m to the power of 3/4. Then from there, the 4 is your index, so that's 1 over the 4th root of m cubed. That gives you exactly what you started with, so you know that m to the power of negative 3/4 is the correct answer here. For example 4, we're just writing each exponential expression using radicals. For example A, we're given 5 to the power of 2/3. This 2 as your power is going to, the 2 as your numerator is going to stay your power. The 3 is your index. So this is going to be rewritten as the cube root of 5 to the 2nd power. This is asking us to keep it in radical form, so we're not going to do anything from here. We're going to leave it that cube root of 5 squared. For example B, we have a to the power of negative 2/5. First thing that you want to do is turn this negative 2/5 into a positive 2/5. So take the reciprocal of what you have. This becomes 1 over a to the power of 2/5. From here, the 2 is going to be your power, the 5 is going to be your index. So this leaves us with 1 over the 5th root of a squared. The next part of our lesson goes over evaluating negative exponents. When we're working with negative exponents or negative powers, we just got to take the reciprocal of the term that it's attached to and then simplify from there. So if we look at example 5, we're just evaluating each expression. For A, we're given 27 to the power of 2/3. Remember, we said that power, that's that fraction, the numerator is your power that's going to stay on the number. The denominator is your index. So this is really the same exact thing as saying the cube root of 27 squared. Now, this can be written in two ways, either the way that we see it here, or we can put parentheses around the cube root of 27 and square our answer. I prefer the second way that's in blue, just because it's easier for me to do that instead of raising 27 to the second power and then finding the cube root of that. If I find the cube root of 27, I have 3 and 9. The 9 is 3 and 3. I'm grouping up sets of 3, so this is just 3 squared, which gives us 9. For example B, we're looking at 4 to the power of negative 3 over 2. With this, first thing you want to do is turn that negative 3 over 2 into a positive 3 over 2. So we're going to take the reciprocal of the 4, and it's going to be 1 over 4 to the positive 3 over 2 now. This is the same thing as saying 1 over the square root of 4 cubed. We know the square root of 4 is 2, so that's 1 over 2 cubed, which is 1 over 8. From here, example C gives us 81 to the power of negative 3/4. Again, we want to turn this into a positive 3/4 to begin with, so we're going to take the reciprocal of it. We're going to have 1 over 81 to the positive 3/4 power. So we're going to be doing 1 over the 4th root of 81 cubed. The 4th root of 81, that 81 is 9 times 9. 9 is 3 times 3. So we're looking for a group of 4 3s. We have that. So that's really 1 over 3 cubed. 3 cubed is 27, so we have 1 over 27 as our answer. For example D, we have negative 8 to the power of negative 5/3. Again, we want to turn that negative 5/3 into a positive 5/3, so this is just going to become 1 over negative 8 to now the positive 5/3 power. We're told to take the cube root of negative 8 and then raise it to the 5th power. So this is going to turn into 1 over the cube root of negative 8 to the 5th power. The cube root of negative 8 is negative 2, so that's 1 over negative 2 to the 5th power. That negative 2 to the 5th power is going to leave us with a negative 32, so that's 1 over negative 32. Now that negative, you can bring it to the front of that fraction or up top. It does not stay in the denominator, so it's just negative 1 over 32. Moving on, if we look at the next part of our lesson, we're using the rules for rational exponents in order to simplify these. So you need to remember, if your bases are the same and you're multiplying, you can add your powers. If you're dividing and your bases are the same, subtract your powers. If it's a power raised to a power, multiply the powers. If it's in parentheses and the parentheses are being raised to a power, that power goes to each part within the parentheses. Same thing if you have a fraction within parentheses raised to a power, that power goes to both the numerator and the denominator. So if we look at the next set of examples, for example 6, we're simplifying each expression. For A, we have 27 to the power of 1/6 times 27 to the power of 1/2. Our bases are the same here. So we're going to keep the base, which is 27, and we're going to add the powers. So we're going to have 1/6 plus 1/2. In order to add those powers, you need like denominators. You cannot add fractions unless the denominators are the same. So your least common denominator between the 6 and the 2 is 6. We'll multiply the second fraction top and bottom by 3. So this is going to be 27 to the power of 1/6 plus 3/6. Now this 1/6 plus 3/6 gives us 4/6, which is the same exact thing as 27 to the power of 2/3. The 3 is your index. The 2 is your power. So this is going to give us the cube root of 27 squared. The 27 is 3 times 9. 9 is 3 times 3. So this is 3 squared, which is 9. So we're working these all out completely. You have to use your rules of exponents in order to simplify into radical form, and then you're simplifying from there as well. For example B, we have 5 to the 3/4 power over 5 to the 1/4 power. We're dividing these two bases that are the same. So we're going to keep the base and subtract those powers. So we're going to have 5 to the power of 3/4 minus 1/4. In this case, your two fractions share the same denominator, so we can just subtract the numerators and keep it over the denominator. So this becomes 5 to the power of 2/4. That 5 to the power of 2/4 is the same exact thing as saying 5 to the power of 1/2. So we're just taking the square root of 5. You cannot simplify that any further, so it just stays the square root of 5. For our next set of examples, for A, we have 3 to the power of 1/2 times 12 to the power of 1/2. This is saying to take the square root of 3 times the square root of 12. Well, the square root of 12 is also, if we do 2 times 6, the 6 is 2 times 3, 2 square root 3. So technically we're doing the square root of 3 times 2 square root 3. If you have something like this and you're multiplying two of the same index radicals, you can multiply what's underneath them and multiply what's on the outside of them together. So on the outside of this square root of 3 that starts us off, we have a 1. 1 times 2 gives us 2. Underneath the radical, that's 3 times 3, which is 9, and the square root of 9 is just 3, so we have 2 times 3. 2 times 3 is 6, so our answer for this one is just 6. For example B, we have 3 to the 10th power raised to the 1/2 power. Remember our rules for exponents: when we have a power raised to a power, we multiply those two powers. So this is going to be the same thing as 3 to the power of 10 times 1/2. 10 divided by 2 is 5, so that's just 3 to the 5th power, which leaves us with 243. For example C, we have 2 to the 6th power over 3 to the 9th power, all raised to the negative 1/3 power. Now what I want to do first is to turn this negative 1/3 into a positive 1/3. So I'm going to take the reciprocal of what's inside those parentheses. So this is going to turn into 3 to the 9th power over 2 to the 6th power, now raised to the positive 1/3. Again, I have a power raised to a power with these, so that power, or here, we have a fraction inside, so the power that's on the outside of the parentheses goes to both the numerator and the denominator. From there, I have a power raised to a power for both the numerator and the denominator, so I'm going to multiply those powers. So we're going to do 3 to the 9th power times the 1/3 power, all over 2 to the 6th power times the 1/3 power. 9 times 1/3, or 9 divided by 3, is just 3. So that's 3 cubed over 2 to the 6th times the 1/3, which is 6 divided by 3, is 2. So it's 2 squared. 3 cubed is 27. 2 squared is 4. So 27 over 4 is our final answer for this one. The next part that we are going to be looking at just goes over the same thing that we've been doing. So we're just simplifying these expressions, applying our rules for exponents to these powers that we have. For example, 8a, we have x to the power of 8, y to the power of 4, all raised to the power of 1/4. Again, if you have parentheses and that parentheses is raised to a power, the power goes to each of the terms inside the parentheses. So inside the parentheses, you have the x to the 8th power, which is going to be raised to the 1/4 power, as well as the y to the 4th power is going to be raised to the 1/4 power. When we have powers raised to powers, we multiply them. So this is going to give us x squared times y to the 1st power, which is just x squared y. For example B, we have x to the 9th power over 8, all raised to the 1/3 power. So that fraction inside the parentheses, the power of the 1/3 is going to go to both the numerator and the denominator. So we're going to have x to the 9th power raised to the 1/3 power over 8 to the power of 1/3. Apply that power to each of these, the numerator and the denominator. The x to the 9th power raised to the 1/3 power, we multiply. So we get x cubed. In the denominator, that 8 to the power of 1/3 is saying take the cube root of 8, which is 2. So x cubed over 2 is our answer here. For our next examples, we're still using our rules of exponents and we're just simplifying these all the way. For A, we have x to the power of 2/3 times x to the power of 4/3. Our bases are the same here. Since we're multiplying, we're going to be adding those powers. So we're going to have x to the power of 2/3 plus the power of 4/3. Our denominators are the same, so we're going to have x to the power of 6/3, which simplifies to be x squared. For example B, we have a to the power of 1/2 over a to the power of 1/4. Again, when you have the same bases and you are dividing them or they're in a fraction, keep the base, subtract the powers. So we're going to keep the a, subtract the 1/2 and the 1/4. Again, you need like denominators in order to subtract your fractions. So we're going to multiply the first fraction by 2 on the top and the bottom. So we're going to get a to the power of 2/4 minus 1/4. 2 minus 1 is 1. So that's just a to the power of 1/4. We put this in radical form. I think write your answer with positive exponents only. So we're keeping it in exponential form. This a to the power of 1/4 is your answer. For your last two examples, for C, we have x to the power of 1/2, y to the power of -3, all raised to the positive 1/2 power. So we have a power raised to a power with these. So we're going to separate this to be x to the 1/2 power raised to the 1/2 power times y to the -3rd power raised to the 1/2 power. We're going to multiply our powers since they're being raised to each other. So this is going to give us x to the power of 1/4 times y to the power of -3/2. We want to turn these powers into positive powers in order to end with. So we're going to have that x to the 1/4 power that stays, but that y to the -3/2 is going to turn into 1 over y to the positive 3/2. From here, we're keeping it in exponential form, multiply straight across. We're just going to have x to the power of 1/4 over y to the power of 3/2. For example D, we're given x squared over y to the 1/3 power, all raised to the -1/2 power. Again, I don't want to work with this -1/2. I want it to be positive, so I am going to turn it into a positive and take the reciprocal of what's inside the parentheses. So this is going to be y to the 1/3 power over x squared, all raised to the positive 1/2 power now. This simplifies because that power goes to both the numerator and the denominator. So it's going to be y to the 1/3 raised to the 1/2 power over x squared raised to the 1/2 power. We multiply these powers and we're just left with y to the power of 1/6 over x to the first power. So y to the 1/6 power over x is our answer.